Here's a little side project my buddy brought over. It's an ailing third rail SD9 or SD7 or whatever Bessemer ran. I kind of had one of these and traded it off to him. So we'll have, I think, 3 units now. But this one has a problem. The motor sucks down a lot of current but doesn't produce a lot of torque. So therefore it smoked up the electric railroad cruise board here. And so far, physical damage is just the bridge rectifier. It's 200 volt, 10 amp jobby, and I got some on order. I don't know if the MOSFETs got whacked, but I've been looking them up and I haven't had much luck finding these. I find something similar, but anyway, what's funny is all the other functions work on this once the motor's disconnected. But if you hook up a known good motor, it starts to overheat rapidly again. So anyway, I believe this is an OEM version of the electric railroad board because it's got these like JST headers or whatever they call these, where normally they have the screw terminals kind of like this for all the like the switch and coupler connections and all that stuff. But it just so happens I actually have an electric railroad cruise board with this, what I'm calling the OEM style, because I don't ever recall ordering them like that before. So his R2LC or whatever didn't get smoked, so everything's good. So I mean, this thing does run and drive, but not with its own motor. As you can see, but fine. Do have to get another motor. Maybe Scott Man can help. We'll find out. So here's where we're at on the SD9 repair for my buddy. You can see this is how Third Rail builds their diesels. Pretty neat. They've got, basically what I think they used to call a tank drive. So you see this coupling down here that's hidden by the fuel tank. Nicely geared and stuff. So here's your electric railroad cruise commander board. The R2LC plugs in here on these header pins. This is your MOSFET final output drive, I guess, to the motor. And I believe this is what they call just an H-bridge setup. These kind of work kitty corner from each other to control direction of the motor. I think the signal's coupled in through these resistors here to the gates. Power goes into the I think the drain, and it comes out the source. I can't remember. Anyway, there's some good diagrams if you want to look up what it looks like on Google. Just Google up MOSFET H-bridge motor driver, DC motor driver. So anyway, what had happened was this motor was definitely bad. I took it apart just for the heck of it, and maybe I'll show you later, but I was just doing some commutator measurements to see if I could find a shorted winding, and there were some strange readings on there. So I do have the new motor here. It came from Scott this week. I'm gonna put it in. And right now, this is my board. I just swapped in to try, and I had this Pitman laying around in my stash just to check out the driver and all that stuff. But I'm gonna put the original board back in. It's now repaired. I was able to find the MOSFETs. And I think they're pretty common off of Mouser or DigiKey. I used the DigiKey app and found them. I think it was about 16 or 17 bucks worth of MOSFETs here, these 4. There's P channel on the one side and N channel on the other to give you your full H-bridge reversing control of the motor. Funny thing about the bridge rectifier, although it looked like a melted cookie in there, it worked perfectly fine. I just tested it with my handy 87, world's greatest DVM ever devised by mankind, and to check a bridge rectifier is pretty easy. You should be able to read diode readings from I'm just calling it AC1 and AC2, but both AC inputs to positive should read about a half to 0.637 volts forward bias for a diode, and just the opposite direction for the minus side. And it turned out that thing was fine. I changed it anyway. I was able to scarf one off of an old DC-DR board that was kicking around in my stash. So it was a pain to unsolder. taking off these MOSFETs and stuff too. I don't know what it is about this factory solder, but man, it's so hard to desolder. So a lot of times what I'll do is if I know the component's bad and it's going to get replaced, I'll clip the leads and leave something above the board that I can grab with a pair of needle nose pliers while I heat up the solder joint. You can't see them under here, but man, desoldering some of this stuff's a challenge. And so this is the repaired board. It's going to go back in, and we're going to maybe give it a test run. These are the smoke MOSFETs and the bridge rectifier. So there's some good videos on testing MOSFETs. But the biggest thing for me was, besides doing a little DVM test on them, using the diode test, was the fact that the drain to source was reading like, I don't know, 5 or 10 ohms. It was depending on which one. I think one was actually okay as far as that reading, but that was kind of the telltale. So they're fully conducting across the shorted motor, and being that the motor was shorted to ground, that current was absorbed by the bridge rectifier, and this actually survived. It still reads right and stuff, but I just took it out anyway, just while we're in there. But anyway, these are the bad MOSFETs. Like I said, about I don't know, 17 bucks worth, maybe 18 bucks with shipping from DigiKey. Here's a little quick and dirty generator test for a motor. Here's the new one, and I thought it was kind of fun to try. A DC can motor is basically a shunt motor with a permanent field set up by the poles of the magnets, and by impressing a voltage across the armature, the resultant current flow and the magnetic flux reacts with the field and causes it to spin, produce a torque, etc. But just conversely, if you put a mechanical input into the armature and spin it in that field, you start cutting lines of flux and you can generate a little EMF. So I thought it would be kind of cute to do a little quick and dirty generator test here. And it's not super scientific, but anyway. You can see I can make about 3.5 volts spinning that at full speed, whatever I forgot how fast this goes, but anyway. The other motor I'll show you here in a minute, the one we're taking out, only produced about 1/10 of that voltage. So it's kind of a quick and dirty little test you can try. So here's our bad motor we took out. You can see we're only getting about 1/10 of that voltage out of there. So I don't know, I thought it was a cute little test. You could take a brand new motor and maybe baseline a little generator test like this and write it down and compare the one you're replacing. Well, we got our fresh new motor in here. We've got our repaired cruise commander. Everything seems to be working. I have it running in speed step 1. I'll show you something real quick to test your loop. It is in cruise control right now, and if you're not aware, you can change cruise mode, speed step selection, cruise mode, etc. You can turn it off and run it as a classic open loop motor where you compensate for load and speed changes with your throttle, or cab 1 or whatever. But a quick and dirty test to see if the loop is working is to check the voltage of the motor. We're running. We're kind of roughly about 1.8 volts unloaded. If you put a little load on the wheels, just kind of slow it down, you'll watch the voltage to the motor rise to try to compensate for that load. And if you let go, it'll drop back down to where it was. So I'll show you the difference between this and just what we call open loop mode, no cruise. So right now I turned the cruise off, doing the old aux 1 0, aux 1 brake 7 brake, and got about 1.5 volts, no load on the engine, just kind of lollygagging along here. But you see, if I put a little resistance on the final drive here, the motor will stall. It won't even try to, won't try, the loop won't compensate, so the motor will just stall out. And you'll see the voltage will actually drop a little bit as the motor pulls more current, and maybe we get some losses in the windings, the wiring, the MOSFETs, whatever. But this is a classic open loop mode, so you would be visually monitoring your engine going down the track. Oh, it slowed down. You give it another couple blips on the old cab one or whatever, and you're on your way. So that's the difference. That's a quick and dirty test to see if your loop behaves like it should. And that's that. So before I put this back together for review, my buddy brought this over, and it was in tough shape. You put it on the track, it just drew a ton of current, and you know, if you had a pretty decent breaker, it would pop. You know, engine didn't do anything, sounds, nothing worked. You get a little fart out of the speaker, that's about it. So kind of went in and just kind of gave it a visual and noticed, you know, we had kind of melted looking components, and thought, okay, if the bridge rectifier is gone, that means there's a direct short in the board here somewhere. It's not external to it. A short in the wiring is actually usually no big deal, because you bypass all the components, you know, and all the electrons are on their merry way straight to ground. So we looked at it, and the best way to troubleshoot something like that is with TMCC stuff is just start disconnecting stuff. You could pull the sound, you could pull the motor. The way Lionel and their aftermarket suppliers made stuff was all modular, you know, so, you know, even on their factory stuff, you'd have a motherboard for the R2LC, R4LC, you'd have a separate motor driver sometimes, and then, you know, your sound was living somewhere else. And this is all electric railroad components, so they combine the motor driver section and the receiver and all the I/O breakout, you know, on a motherboard. So you could put this in an engine and not have sounds or whatever, or minimal I/O, like couplers and lights, things like that. And this is an electric railroad. I think it's a Rail Sounds Commander. It's single board solution, kind of nice. And this is the serial connection to it, power serial off the motherboard here. And then it's got, you know, connections to the speaker, and I think a signal sound switch and all that sort of stuff. So pretty basic TMCC setup. And there's a smoke unit living in there. And when I put it back together, I'll show you what Third Rail did for all the access to the switches. Pretty cool. Here's a couple shots of those suspect MOSFETs. I was able to get them from DigiKey, so I'm including a screenshot of my order. Let me know if you can't make this out. I can put the part numbers in the description or comments, whatever. Here's a few shots from 2017 of my 823, just kicking around on my layout. I did trade this off to my buddy, so now he's got two of this same number.